JPA, or Java Persistent API, it's a type of ORM. It's an object relational mapping API that allows us to very easy map Java objects to databases or tables that would allow us to map all the fields in an object to fields in a database, right? So that whatever we do to objects in memory, they would be persisted in a database, right? So if you create instances of objects in memory, you could very easily just say, take this instance of an object and store it in a database, right? This would be entirely from within Java, and JPA would then translate these things to underlying SQL queries, such as inserts and updates and deletes. So basically, you would not have to deal with actual nitty-gritty SQL commands to generate this. It also is aware of the impedance problem, right? That exists between the relational world and the object world. There are many things in the object world that are not supported in the relational database, right? For instance, inheritance is not supported, right? There's no such thing as some kind of hierarchy in tables that would allow you to say that certain fields, certain attributes in some entity can be inherited by others, right? There's no such support. So JPA provides this support so that it can use the low level flat representation of tables and pointer and foreign keys and primary keys, and it builds for you a way to represent these inheritance relationships in objects, but represent them in tables, right? And we'll do the conversion for you. Also, in object-oriented world, you have all sorts of things, ideas that are just have no equivalence in relation, or might have different ways of implementing the same thing. Where in the object world, when you have a one-to-many relationship, typically you represent that by having some parent class have a collection of children, right? Where you might have either an array or lists, a collection of children, and usually the children are unaware of their parent. They just exist as an independent instance. And so usually you access the children from the parent, right? You iterate over the children from the parent, from algorithms and functions in the parent. In relational database, it's kind of the opposite. It is the way you implement one-to-many relationship. It is the children who have references back to the parent, using foreign keys, back to primary keys from the parent. It is the parent who is unaware who the children are. The parent has no references, no collection or anything that would let them know who the children are. So all these discrepancies between how you represent things, how you model things in one world and in another world, right? It's a hassle having to bridge these two worlds. So ORMs, or object relational mapping tools, take care of all that underlying mechanisms for you. And JPA is just one of these ORMs. There's plenty, a whole bunch of them in the market. Each infrastructure has its own ORM solution. So .NET has its own, Python will have its own, and PHP and different infrastructures will have its own implementation of this mapping between these two worlds, right? So basically what we're trying to do is map something that is ephemeral, or something that is very temporary, that lives in memory, in RAM, for milliseconds, right? For very short amounts of time as a computation executes, a thread executes through some code. We're trying to map that ephemeral world to something that is permanent, right? That has long-term storage, right? That maps something that in memory we have not only a small amount of time, but also small amounts of memory, right? Things that might be couple megabytes, and trying to map that to things that might be several gigabytes or terabytes of data, right? And so we're trying to bridge those two worlds. It's not trivial, and ORMs allows us to do that, right? It allows us to bridge that world. So JPA. So the first couple of slides here just walk you through just setup creating an application. We already do have an application, so I'm going to skip through some of these. But most of these slides start from scratch, right? From scratch. Right? Don't assume any particular prior knowledge. So here's just a walking through setting up a really simple web application, which we already have. One thing that is new here is that we're going to use a file called the application.properties file, which is part of every Spring Boot application. So typically when you want to programmatically talk to a database, usually the database is its own process, right? So its own server listening on a particular port, and the way we typically talk to this programmatically is by establishing a connection, right? So there are libraries, JDBC being the more common library, that we could easily just establish a connection ourselves and start sending SQL queries to a particular port on that server, on the database server, and the server would then interpret these SQL commands and execute them, right, for us in the remote server, right? And these might be apart geographically. The database is running somewhere in Eastern Europe, and in our server it might be running on the West Coast or whatever, right? They could be in completely different parts of the globe. So these connections are fairly expensive, and usually we want to economize on having to establish the connections and make the best out of these connections. And it's very expensive to create the connection, and then when we're done, just throw it away. And then when we need to talk to the database again, reestablish the connection. They're very expensive. So typically we don't go that route. Instead, we delegate this lifecycle management of the connections. We delegate it to the server where we're running, right? In our case, maybe Tomcat or Oracle or whatever database server we're running on. We configure the server to say, hey server, create for me a couple of connections, have them up and running, all ready to go, and whenever I want to talk to a database, just give me one of those connections, right? Typically it's called a pool of connections, where the server at boot time will establish 10 connections ready to go and won't let them go until the server goes down, right? So it pays for the expense of establishing this connection just once, right? And keeps them available. Any thread that is running on the server can ask for a connection from the pool. They're handed a reference to the connection. They use it, and then they release it for some other thread to pick up that connection. And that way, we can economize on the having to create and destroy these connections. So the way you configure these pools, these connection pools, in Spring Boot anyway, is through the application.properties file, right? That lives under source main resources, and it's application.properties, right? So under there you can there's several properties. These are Spring Boot properties and JPA properties, and you can establish, for instance, where does the server live, right? Where is it running? It could be an IP address, so if you know the URL, you can establish it here. Also, typically notice that the URL has a syntax. Typically starts with JDBC : JDBC. So the first couple of tokens there are the what I call the protocol, right, to establish, to connect and communicate. JDBC being the low-level library that talks to the database, right, on top of which this ORM is built on top, right, to hide all the details. Then in this case it's MySQL, but different vendors will have their own syntax, so you should check with whatever vendor you're actually using. So in this case it'd be MySQL, it could be Oracle, it could be SQL Server. Each vendor will have a different protocol, followed by the name of the machine where this is being hosted. Typically the port number is 3306, is a common SQL Server MySQL database port, and typically followed also by the name of the database. So this assumes you have already established a schema in the database, in the server. Then other things that you can configure here are the username and password. A couple other things here are the JPA. These username and password, typically you have already established a user and password for the user that you're going to use, either manually or when you purchase or when you configured it, the vendor will give you the username and password for you. Also notice here down below that you have a couple of JPA configurations: Spring.jpa, Hibernate, DDL, and so what JPA can do for you is to look at your Java classes and see that you have users and modules and courses, and you have all these Java classes hanging around. And what it could do is explore the schema for your classes and say, oh, well, you have all these fields of this particular data types. It can for you, if you have this DDL, that's the data definition language, right? It will create for you, for every class, it will create a table, right? And it will also, for every field, every property in your class, it will create a column for you in those tables, automatically, automagically, I like to say. And using the correct data types, right? Making certain guesses at what, pretty good guesses on what you want to call the classes or the tables, what you want to call the fields. Right? It'll use correct naming conventions. For instance, in Java, you use camel cases, with uppercase and lowercase. But SQL is case insensitive, right? So it'll use underscores as opposed to uppercase and whatnot, right? So it'll do all that for you. So this dash auto equal can be different values. It could be none, meaning don't do that. Do not create the schema for me. It could be create. Create means drop any schema you have there, any tables that you have there. Even if they have data in there, just throw it away, just drop it. Just recreate everything from scratch. Okay. And then there's update. Update is if it's not there, create it. But then afterwards, don't just throw it away anymore. Right? Just do incremental updates as maybe I've added a new field, maybe I renamed the field, maybe I changed data types. Do alters, alter the existing schema that is already there. Now, for us that we're starting from scratch, that we have a brand new database, and we have full control over the database, we own it, right? It's ours. Equal create might be a good practice at the beginning, to get us started, right? It'll create the table, all the tables for us, the foreign keys, primary keys, mapping tables. It'll do everything for us, right? And this would be a good, just to get us started of what the schema and the tables might be. But once the project progresses and it matures, it makes no sense to throw away that schema that you already have, right? So you might want to change it to update instead of create. And eventually, once you're settled and your schema is good, you don't really want to change that ever again, right? Or make very small incremental changes yourself. And you might want to change it to none. That's very important, right? Because if it's create, will throw away any data you already have there. It'll drop every time you restart the server. It'll drop the tables or recreate. And maybe that's not what you want. You might have important data in there, especially if this is a legacy database, right, that has been there for years. You don't want to drop anything there. You just want to connect to it, right? So in that case, you make sure to have this configured to none. Right, that would not allow you. Oftentimes, you'll be giving a read-only account, right, where you can connect to a database, where you have only read-only operations, or that you don't have DDL. You can do inserts, you can do updates, right, but you can't do any DDL, data definition like create tables or alter tables or do anything to the schema. So usually, what the system admins will give you, the right account for you, right, with the right permissions. But for us, I think update is a good start. So update is a good start. The other one is show SQL equal true. So that allows us as developers, while we're developing, oftentimes we would as we are writing tables and writing code, we would like to see what JPA is doing as it talks to a database. Right, we want to see the create statements and the inserts and the updates and the deletes. It's very interesting to see the actual SQL that is going out to the database, and it's pretty cool. Oops, sorry. So we can turn it on and off, but it's mostly for us, for developers. Once this goes into production, we totally would turn that off, right? And we don't need that anymore because we're not developing anymore. A couple other things, configurations such as naming strategy. So, for instance, the JPA will make a best guess at what the field names are based on the names you gave them in Java. So any capital letters, it'll transform into underscore lowercase, right? So it'll use underscores as opposed to camel casing. So you can configure that how you want to name it. Also, the dialect that you want to use of SQL. There are many different vendors that they compete amongst themselves, and they might have certain variations on the SQL. So JPA can be configured to talk any vendor. Right? You just need to tell it what vendor are you using, and then it'll use that correct dialect for that particular vendor. A couple other things. You can turn on even heavier logging to format your SQL. To add tabs and new lines so they can pretty print the SQL that is sending over. So that again for trace, it can trace any data communication to the server. So that, again, for debugging purposes, is great, right, to see what's actually happening underneath. So that you'll need to configure that in your application.properties, right? The other dependency that you'll need to configure is in your POM file. You'll need to establish your SQL library as a dependency, right? You'll have to say, have download the JPA libraries, right? The ORM itself, and also depending on the vendor who you want to talk to, the different vendors will have different drivers, right? They will know how to talk to MySQL or SQL Server or Postgres or whatever vendor you're using, right? So the other dependencies down below here, I'm using MySQL 8, right? So depending on the version that you're using, you'll need the correct version here. Okay, this is one of the later ones, and so this should work if you've downloaded the latest MySQL server locally on your local machine. This should work fine locally.